All right, in this worked example, we're looking at the diameter of a solid metal sphere is measured using a micrometer screw gauge. The diagram shows an enlargement of the shaft of the micrometer screw gauge when taking the measurement. The mass of the sphere is 0.450 grams. What is the density of the metal used to make the sphere? So different strategies to solve this. Some students will want to immediately realize that density is mass per volume. And looking at the units, kilograms per cubic meter, we should convert this sort of right away. And so you could do a very formal conversion and say, I want grams in the denominator, kilograms in the numerator, and there are 10 to the 3 or 1,000 grams per 1 kilogram. So we divide this by 1,000. It's like moving the decimal point over like 1, 2, 3 places if you're sort of comfortable with that, or if that's a nice shortcut for you. So in scientific notation, we get the mass 4.5 by 10 to the negative 4 kilograms. Now the volume is the volume of a sphere. So if you don't know the volume of a sphere, it is something that you should commit to memory. Does anybody know it? It's 4/3 pi r cubed. 4/3 pi r cubed. That's just something you have to memorize. Okay, you've got to know that. The volume of a sphere is 4/3 pi r cubed. Now we have to read off of this instrument what the diameter is, because it says the diameter is measured, right? We can't measure the radius. We can calculate the radius from the measured diameter. So here we've got 4, like 3, 3.5, 4, right? So this is 4.5, but then they move the spindle, okay, around, and this sort of measures off fractions of a millimeter. And so the way to sort of think about this is that already to right here, we've got 4.5. And as we spin this around, it's eventually going to sort of get back to 0. And by the time it does, it's going to be past, the next line. It's going to be at 5, right? And it's going to sort of reset. And so it's a very sort of precise instrument. If you look, this line right here corresponds to 31. So it's saying we've got 4.5 plus 0.31. Like we're that much closer to 5. Okay, so the actual reading here, and this is in millimeters, is going to be 4.81 millimeters. That's how accurate we can measure the diameter of this sphere, right, to the hundredths of millimeters. And so that's the diameter. Let's change it into a radius, and let's get it into the units we want, cubic meters. And so I'm just going to divide this by 2 right away. It's like, let's get the radius in millimeters. 4.81 divided by 2. So the radius of our sphere is 2.405. And let's just convert it right now. Millimeters, right? We know that milli is 10 to the negative 3. Now I've got a number I can substitute into my formula for the volume of a sphere. Calculate that. Plug it in over here. Another calculation, your favorite. Multiple calculation problems. All right, I got 2.405 in my calculator. I'm going to times it by 10 to the negative 3. Cube it. So I get the r cubed, and then times it by pi, times it by 4, divided by 3. And so I get a volume of 5.83, 5.826, and so on, by 10 to the negative 8 meters cubed. All right, so the final step is just to take the ratio of mass to volume. That's what density is. So I've got 4.5 by 10 to the negative 4 kilograms divided by 5.83 by 10 to the negative 8 meters cubed for a density of 7,718.7, which I wrote underneath this one because it's closest. All right, 7720. Now we can look up what metals, have known density of 7720, and we might be able to identify, that metal based on the density. All right, so that's one of the ways to, sort of identify an unknown substance, is to sort of look at its density. It won't always work. It could be an alloy, that has a different density. So we don't know.